Hey guys, I'm Pat Kelly. Okay, in this problem, we're supposed to use this function value that they give me to find the indicated trigonometric value in the specified quadrant. Okay, so I've got all this information that they give me, and then to start, what I'm going to do is recognize that what they want of me, this cosecant of theta, I can rewrite that, if you know your identities, which you should. This equals 1 over the sine of theta. Okay? And the reason why I want to start with that is, now let me slide over here and do some more work, is if I know that my answer is dependent on sine of theta, but what they've given me is something that involves cosine of theta, I'm going to try to find a relationship between sine and cosine. Right? You got to know your identities. This is the Pythagorean identity, one of the more important ones. So what you should know is that the cosine squared of theta plus the sine squared of theta, that always equals 1. This relationship between sine and cosine is going to take me from what I know to what I want. Now I'll plug in my specific, just this one value of 5/8. I now know that 5/8 squared plus sine squared of theta equals 1. And I'm trying to get sine of theta alone. I'll keep it squared for a step. And now take this 5/8 squared and subtract it over to the other side. So I'm going to have 1 minus 25/64. Right? As I go down a step, I said that we want to get sine alone. So now I'm looking to take the square root. And when I take that square root, I will have a plus or minus. And then on the inside of the square root, the radicand for us in this case, let's do this arithmetic where if I'm going to combine these, my 1 I'm looking at is 64 over 64. So 64 minus 25 looks like 39 over 64. Okay. And that's pretty good. It's good algebra so far, but we also want to infuse a little bit of trigonometry because I don't want the plus or minus, and that's why they gave me this other piece of information that I'm in quadrant 1. Okay, so now I'm thinking in quadrant 1, you know something about the sine of theta. You know that the sine of theta is positive, greater than 0. So what that tells me is this algebra that we did, and we did correctly in terms of algebra, I can actually trim off that minus. It's not plus or minus anymore for me in quadrant 1. Sine of theta in this problem is just the positive version of this, so plus the square root. And in this step, let me also even break this down. I think it looks a little bit better with the denominator since it's a perfect square. Let's take it out of the radical and just make it 8. Right? But the key work we did in that step was recognizing that in the first quadrant, we don't have the or minus part of it. Okay? So this is really good, and we're pretty much done if we just now make the connection to the fact that we know what sine of theta is, and we know that this cosecant of theta that they wanted of us is 1 divided by sine of theta. That means this cosecant that they want equals 1 divided by this fraction, which means I'm flipping it. So I'd have 8 divided by the square root of 39. And I really don't think there's any shame in this. I'm going to go to a calculator because of that imperfect square under the radical. So let's find 8 divided by square root of 39 on a calculator. 8 divided by square root of 39, approximately 1.28. And that's my final answer. Practice some more on your own.